Composite functions are when we take functions of functions. And the notation that is f of g of x, which can also be written as f of g of x. And what this is doing is that we're finding the function value for g of x, and then we're taking whatever that's equal to. So whatever y we get from g of x, and then we put that y into f. Then we find the function for that, the function value for that, and then we have our answer. So let's illustrate this with an example. We'll do f of x is equal to 2x minus 1, and g of x is equal to x squared plus 1. And we'll do a numerical example first. So we'll pick a function value and we'll solve it like that first. So I want to know what f of g of 2 is equal to. So again, what we're going to do is we're going to find the function value. We're going to take g of 2, find out what that is equal to. We're going to take that y, and then we're going to put it into our f of x. Actually, we're going to be putting it in for this value. So whatever this y is equal to, we put it into our f of x, and we'll replace our x values over here, and then we'll get our final answer. So let's find out what g of 2 is first. So g of 2 is equal to 2 squared plus 1, which is equal to 5. So now we have our 5. We take our 5 and we put it into f now, because now we're taking the function value of g of 2, and g of 2 is equal to 5. So now we do f of 5. So f of 5 is equal to, what's it? Oh, it's 2 times 5 plus, no, minus 1, and this is going to be equal to 9. So f of g of 2 is equal to 9. But we can also make an equation out of this, so we can very easily find what multiple values of f of g of x are equal to. So let's do that. So we know that, well, let me rewrite our equations down here. So f of x is equal to 2x minus 1, g of x is equal to x squared plus 1. And if we want to know f of g of x, instead of solving for a numerical value, what we can do is plug in our g of x for f of x. So this is the same as saying f of x squared plus 1. It'll give us the same answer. So what is f of x squared plus 1? This is equal to 2 times x squared plus 1 minus 1. And this is equal to 2 times x squared, which is 2x squared, 2 times 1, which is 2, minus 1, so plus 1. So this is our answer. So if we put x in for 2, like we did originally, we're going to get 2 times 2 squared plus 1. So 2 squared is 4 times 2, that's 8, plus 1 is 9. So we got the same answer that we did over here when we did each of them independently. And it's also useful to know that we will get different answers if we do g of f of x, because we are transforming the numbers differently. So let's find out what this would be. So our g of x is, let's rewrite them. Our g of x is x squared plus 1, and f of x is 2x minus 1. So if we did g of f of x, this would be equal to g of 2x minus 1. And that would be equal to that's the wrong one. 2x minus 1 squared plus 1. So 2x minus 1, we're going to have to FOIL that out. We're going to get, let me rewrite it over here. G of 2x minus 1 is equal to 2x times 2x, so that's 4x squared. 2x minus 1, so that's going to give us minus 4x. Minus 1 times minus 1 is going to give us positive 1, plus a 1 over here, so this is going to be plus 2. And this is not the same as f of g of x. This is going to give us a different number. And that's all there really is to composite functions. We can do multiple composite functions. If we had a third function, we could do h of g of f of x. We can have as many as we want, and it's the same procedure. We would take f of x, we would get that answer, then we would do g of that answer, and then we'd finally do h of that answer, and then we would finally get some value.